So here we are going to determine the rate law for this reaction right here. So I'm going to write out, start writing my rate law. So I've got two reactants here. So I'm going to draw some brackets around both of my reactants here. And then here is what my rate law is going to sort of look like. But for now, I'm going to just put a x where my exponent is, because I don't know what that exponent is yet. And then I'm going to draw brackets around my second reactant. And I'm going to put a y to represent um, the exponent here, because we don't know that exponent yet either. So here we have some data. And first thing I'm going to do is I'm going to worry about my first reactant here, hydrogen peroxide. And I have the concentration of each of my reactants, and these are 1, 2, 3, 4 different experiments. And these are my concentrations, and this is the rate of reaction. So for my first reactant here, I'm going to look at hydrogen peroxide, and I look at the difference between the concentration with all these different experiments here. I see that in the first experiment, I have 0.01 concentration, and in my second experiment, I'm doubling the concentration. Look over here. My other reactant in the first experiment is 0.01, and then in the second experiment, it's also 0.01. So these two concentrations are different, while these two concentrations are the same. And these are the rates of reaction. So for this reactant, I'm going to compare, make this look more like a comma here, experiments 1 and 2. So here, down here, I'm going to put R2 over R1, and then I'm going to take the concentration. I'm going to take my larger number, and I'm going to put that one on top. That's my concentration at experiment 2. And then I'm going to put the concentration of experiment 1 underneath here. And I'm going to go ahead and put some parentheses around this. And then I'm going to figure out what my x is. But in order to figure out what my x is, I'm also going to take my rates over here. So I'm going to take my rate of reaction, my initial rate, for rate experiment 2, and then I'm going to divide it by the rate in experiment 1. And so if I divide 0.02 by 0.01, I simply get 2. So 2 to the x, let's see what this is equal to. Now when I divide 2.3 times 10 to the negative 6 by 1.15 times 10 to the negative 6, I also get 2. So 1 to the x power equals 2. So that tells me, put a little comma here, and I can tell just by looking at this that my x is equal to 1. So in writing my new rate law over here, rate equals k times, and I'm going to put my hydrogen peroxide in there. And then normally I don't have to put a number here if I have an exponent of 1, but just for completion's sake, I will go ahead and write that one in for me. So now what I'm going to do is I'm going to do the same thing. Let me clean off, give myself some room here. And I'm also going to change the color. So this time, I'm concerned about my other reactant, which is the iodine ion. So I'm looking at my concentrations here. I notice that this is the only experiment where the concentration changes at all. And then I'm going to look at the concentrations, the corresponding concentrations, and I notice that in experiment 1 and 3, the concentration of my iodine is different, but the concentration of my other reactant, my peroxide, is the same. So if I compare these two experiments, rate 3 with rate 1, then I can see what the effect of iodine is. So now I'm going to set my problem up the same way I did with the other reactant. And I'm going to write out, and I'm going to take my larger number and I'm going to put that on top to make it easier to divide. So I'm going to take my concentration of iodide at experiment 3 and divide it by the concentration of iodide in experiment 1. And I'm going to put parentheses around that, and then I'm going to put my little y right here, because that'll show, because this is what I'm trying to find right here. And now I'm going to take, I also want to consider the rate of reaction between experiment 1 and experiment 3. So now I'm going to take my rate of reaction with experiment 3 and the concentration here, and then I'm going to divide that by my rate at experiment 1 right here. And then I'm going to see what I end up with. So once again, 0.02 divided by 0.01 simply gives me 2. So this is 2 to the y power. And if I divide 4.6 times 10 to the negative 6, then I will get 4 out of that. So 2 to the y power equals 4. My y, in this case, equals 2, because 2 squared gives me 4. Now, I'm going to switch back to my original color here for my rate law. And I'm going to draw brackets around that, and I'm going to put a 2 over here. And so now I have determined the rate law based on this experimental data.